This is Jamie Philpott, just doing my video for the mean proportional, just explaining. So what we're going to start with is we're going to draw a rectangle, just 9 wide, and we're going to go 4 high. So now, there's my rectangle. Let me just continue it. 4 high. Now, so what we have to do is we have to get this line here and swing it down here so we can get a nice even straight line. So what we'll do is we'll just add 4, so up to here. Now if we swing an arc from the base of the rectangle here to the 4, then as you can see it lines up just like that. So now there you have your rectangle, which are 9 by 4 with an area of 36. And so what we have to do is we have to get a square that's the same area. So I'll just do a quick skip. So your square, which is 36 area, has to be 6 by 6. But what we have to do is get the mean proportional here, so that we can get the length 6 here, so that we can prove the mean proportional. So what we do is we bisect this line, and since we know that it's 13, I'm just going to draw another line down here to make it easier to see. So on pencil, 13 length, you go 6.5. Now so there we have the semicircle. So we're going to go across 9 from the edge, just so that we can get this edge of the rectangle. And we're going to go up vertical, just till it cuts the semicircle. Now, so that's 6 centimeters there now, so 600 mil. So that's our mean proportion. So what I want to do is join one edge of the semicircle to where the mean proportional touches the semicircle, and join that back again. And as we know, this angle in here has to be 90 degrees because it's touching the circumference of the semicircle and it's touching the either side of the diameter. So now we have to just start putting numbers on this. So we know that's the right angle and that's the right angle. So when we start putting numbers on them, we let them first. So we go A, B, C, D. So what we have to do is we have to prove that this triangle here, BCD, is equal to the triangle ABC, or is similar. So what we have to do is we just put numbers on it. So we go for angle A here is 30 degrees, which means this has to be 60, as this is 90 degrees. So then, as we know this is 90 degrees up at angle C, we know 90 takes 60 is 30, so the angle has to be 30 and this angle has to be 60. So there we have it. So now we know that, by the way, the three angles are the same, means that the two triangles, we just do another quick sketch. So A, B to BC, and C back to A. So there's a triangle ABC. So now what we're going to do is we're going to get the triangle BDC, and we're just going to flip it so that the line BC is lying horizontally. So we just do the triangle. So now since we flipped it, we know that this point is C, this point is B, and this point is D. So 60 and 30. So now, since we know from our theorems, we know that these two triangles at similar triangles as they have 3 equal angles. So now we know that there's just the same triangles, just in different proportions. So now when we have to confirm our mean proportional line, what we have to do is we have to prove that these two triangles are proportional. So how we do that is we do A over B by B over C is equal to B over C is equal to B over D. So now we have that now. So now what we do with these fractions is we cross multiply. So we multiply this by this and this by this. So we have BC squared is equal to AB multiplied by BD, which means BC is equal to the square root of AB multiplied by BD. So therefore we can see here that the line BC is equal to the square root of AB multiplied by BD. And as we know that A by B, A to B is 9, as you can see, and B to D is 4. So A to B, which is 9, multiplied by B to D, which is 4, gives us 36. And B to C is the square root of this 36, which is 6. So when we measure it, it works out to be 6. So therefore you can see that this proof works, and therefore with this method we can find out what our mean proportional line actually is.